Okay, good morning students. As you know, my name is Subut Pandey and you are floating with me in the world of physics. Okay, we have discussed about the wave nature of the light and earlier I have also explained that there was two famous scientists. One was your Newton and in the same time period there was another scientist and the name was huygens. Okay, and if we talk about in the era of the both scientists, then according to Newton the light is made of the corpuscles or we can say particle, whereas in case of huygens believed that the light is made of wave. Okay, so we can simply say that light is nothing but it is a wave. So for that according to Huygens, because we are going through the wave optics, that's why we have to follow the Huygens theory. So it is very necessary that we will discuss the points which is defined by the Huygens. Okay, so basically as you can see on the screen, it is written that we are going to study Huygens principle. So let's get started. First point is that Huygens consider what Huygens consider. Huygens considered light to be a mechanical wave. Means we can simply say that the according to Huygens the light is like a mechanical wave. Okay, and if it is a mechanical wave, it means it required a medium, and according to Huygens the medium was hypothetical. Hypothetical means which is not real, that's why it is called hypothetical. So hypothetical medium, and that was ether. So that is the first point which directly explained by the Huygens. Okay, so Huygens told us that light is like a mechanical wave, and in support, because we know that if there is a mechanical wave, so it is in need of a medium to travel. Okay, so in support of the mechanical wave, he introduced at that time medium as an ether, and ether is a hypothetical medium. Okay, so this is the first point that we should know. Now second point, to what they believe, according to him we can simply say that if we consider a surface sigma enclosing a light source as the optical disturbance at any point beyond sigma must reach after crossing sigma. What it means, as you can see in the picture, it is clear that if S is your source, this is your source. Okay, and we can simply see that here this sigma is your surface. So this is your surface, you can see clearly. Okay, and this S is your source. So if we consider that S is a source which is producing wave like this way. Okay, so the waves, the mechanical waves are moving in all possible direction, we can simply say that. So like this way you can represent as I am trying to show you. Okay, so this one like this one, so in all possible direction the wave, or we can say the mechanical wave will move. Okay, so basically as we can easily see that each and every wave must cross the surface. If that particular wave, let's suppose this wave is trying, or that wave is trying, or this wave is trying to reach to point A. Okay, it means it is compulsory, it is necessary that these waves must be crossed the surface that is sigma. Okay, so we can simply conclude that if we have a source like this way, S be your source, okay, and a wave is emitting out from this source, okay, and if we consider a surface which is enclosing that source like this way, okay, and we have a point, let the point be A, and the wave wants to reach to that point, then it is necessary that this wave should cross the surface. This is the first criteria, means we can simply say that if we have any surface, any arbitrary surface, arbitrary means any shape of the surface we can take here, okay, so if we have a surface which encloses the source of light, and we have a point which is outside from that surface, so each and every wave which wants to reach up to that point must cross that surface. So this is the second key point which is suggested by Huygens. Okay. Now third point is that the particles on the surface sigma vibrate as the wave from S reaches there, and these vibrations cause the layer beyond to vibrate. What does it mean? It means simply you can see that if we take the example of a pond, okay, so let's suppose this is your pond, okay, in Hindi you can say talab, okay. Now if we have suppose we throw a stone in it, so this be the direction, and finally the stone is strike to the surface of the water layer. Now what we will see? We will see that the waves are we can say that started from that point at which the stone strikes, and continuously moving in the forward direction like this way, okay. So you can simply see this pattern on the surface of the water, and this is called the disturbance. This is called the disturbance. This is called the wave, okay. So we can say simply wave, we can say the disturbance, both are same. So it means we can simply say that as we have considered here that we have simply draw a new diagram for you, that here we have considered that we have a source S, we have a surface like this way which is enclosing that source, okay, so that is your surface, and beyond that surface we have a point A, and the wave is emitting out from the source like this way, and after crossing the surface sigma, this wave, this pulse reaches to point A. It means if we consider that this surface has some particles like this way, suppose these are the particles which are on the surface, okay, so this disturbance, or we can simply say the wave or the pulse, reaches and strike to the point, let be point P, okay, so it will strike to the point P. Okay, so what we can say that? We can say that due to the disturbance which is coming from the source S and reaches to the point P, is responsible for the disturbance in point P also. What is it mean? It mean we can simply say that because this surface is that surface which is enclosing the source of the pulse, then we can simply say that what type of vibration are producing by the source, the same type of vibration must be on the point P, but there must be some time lag between them. Let be the time is taken to reach from point S to point P be delta t. Okay, so after time delta t, we can simply say that the point P which is on the surface sigma, that also vibrate in the same pattern as the pattern of the source. Okay, so we have few things as we have discussed up to here, that firstly we have to consider the light wave as the mechanical wave, and second thing that for the motion of the mechanical wave there is a need of the medium, so we can take ether as a hypothetical medium. This is the first point. I hope that it is clear. Second point, that if any surface which is enclosing the source is there, then if any wave, any pulse, any disturbance wants to reach up to any point which is outside the surface, then it must cross that surface. And the third point is that if the disturbance is crossing the surface, then each and every point must be in the same vibration as it is produced by the source itself. So I hope that these basic points are now clear to all of you. Now what? We can thus assume that finally that the particle on sigma act a new source of light. So as I have told you that this source is producing a special type of vibrations, a special type of waves. Okay, and due to this vibration, due to this disturbance, a particle which is on the surface sigma also in the same vibrations. It means we can simply say that if S is your source, then the point P will behave like a new source. Okay, because both are in the we can say that in the same pattern, or the same disturbance is responsible for the vibration in the source as well as the point which is on the surface. Okay, now we can simply say that after the wave which are, we can simply say that which are passing through the point P and reaching to the point A, that is we can simply say that follows the superposition of the spherical waves. Means not only one wave is reaching up to point A, but we can simply say that there are the combination of waves which are reaching to the point A after crossing the surface sigma. Okay, what does it mean? What I am trying to say, that this is your source S, this is the point P which is also in the same disturbance, so this is your primary source, and this is behave like your new source, or we can say that secondary source. And because as I told you that from the source each and every direction the waves are emerges out, it means at point P also in each and every direction the waves must be going on. Okay, and as the point A is here in this situation, means it is beyond the point P, it means at point A there are several waves are reaching like this way, you can simply say that, and due to the superposition of the waves, finally we have a wave that strikes to the point A or reaches up to the point A. So I hope that this thing is clear to all of you. Now what? Huygens called the particle spreading the vibrations beyond them as secondary source. So I have told you that this is new source is your secondary source, and the spherical wave fronts emitted from these secondary source are secondary wavelets. So these waves which are coming from the secondary source are the secondary wavelets. So secondary wavelets. So this is the basic pattern, basic things you should know, that there are three things there. First is your main source, second is your point which is on the surface which is enclosing that source, and the next point is your A, which is any arbitrary point up to which the waves should be reached. Okay. And due as the disturbance reaches to the point P which is on the surface, and after crossing the point P it finally reaches to point A, and the point P is having the same disturbance as the source, so it is the new source of the disturbance or new source of the wave. So this is called the secondary source. And the waves which are producing from the, or we can say that emerging out from the secondary source, are basically your secondary wavelets. So I hope that up to here each and everything is clear to all of you. Now we have Huygens principle and the statement is clear. Various points on an arbitrary surface, when reached by a wavefront, become secondary source of light, emitting secondary wavelets. So this point is clear to all of you, that we have a source, we have a point on the surface, and the waves or disturbance reaches from the source and originating from the source and reaches to the point P, and the point P behaves like a secondary source. So it also we can say that regenerates the waves in all possible directions. Okay, and the waves which are emitting out from the point P, that are the secondary wavelets. And the disturbance beyond the surface results from the superposition of these secondary wavelets. So this thing is clear to all of you, that after point P, whatever point we have, it may be A, B, C, D, whatever. Okay, so what amount of waves or disturbance are reaching up to that point is due to the superposition of the multiple waves. After that, we are in the situation that we can handle each and everything very carefully. For that, we have a representation here. We have to draw the each and everything what we have thought about. It means we have to simply draw your primary source, we have to draw your secondary source, then we have to draw the wavelets also. So as you can see in the picture, that we have a source S, it is, and a spherical surface sigma with its center at a point source. So this sigma is this is your surface, spherical surface. You can see this one is your spherical surface sigma, and this surface is enclosing the source as I have already explained to you. This is the first step. And the source is emitting a pulse of light. Okay, so a pulse of light, we can simply say that the pulse is moving like this way. The optical disturbance reaches the particle on sigma at time t equals 0, means this pulse is reaches, and when it reaches to the surface sigma, at that time is taken as 0. And last for a short interval in time, which the positive and negative disturbance are produce. Means as it reaches to the surface sigma, then the time is taken as 0, and after let time t, it reaches to the surface sigma, this one. Okay, so we can say that the time to reach from surface sigma to capital sigma, we can simply say that time is b small t. So it takes time t for any pulse to reach from surface small sigma to capital sigma. Or we can simply say that up to or in this time interval the optical pulse remains. Okay, now what? These particles on sigma then send spherical wavelets which spread beyond sigma. So as the pulse reaches from source S to this is your surface, okay, and this is your small sigma surface. Let be this is a point which behaves like a new source. It means in all possible direction the waves should be emerges out like this way. Okay, and when we draw a wavefront, then the wavefront will be in the spherical shape like this way. Okay, so this be your new wavefront, you can simply say, and the shape will be like this. So this is for any point, general point P. Similarly, we have point Q on this surface, we have point R in this surface. Okay, so there are several points, and we can simply say that here it is given point S2, it is S1, it is S3. Okay, so each and every point on the surface will behave like a new source, and that's why the disturbance arises in all possible directions. Okay, so we can simply see that each point either S1, either S2, S3, S4, S5, or there are several points. From each and every point the light waves emerges out in all possible directions. Okay, and because it is moving in all possible directions, that's why it is taken as in spherical shape. Now one thing you should know that if we draw a wave like this, we can simply say that wave is represented by either a sine function or a cos function. So we have a positive amplitude, we have a negative amplitude. In same pattern we have the positive disturbance or negative disturbance. So we can say that the dashed line represents negative disturbance, whereas the positive disturbance is represented by the solid line. So this is your dark line or solid line, and this is your dotted line. So dark line represents the we can say that represent the optical disturbance, or we can say positive optical disturbance, whereas the dotted line represent the negative optical disturbance. And what is the positive disturbance? As I have told you that positive amplitude, and negative optical disturbance means negative amplitude. Okay, now we came to the surface capital sigma. So if we talk about the surface capital sigma, is the geometrical envelope on all the secondary wavelets which were emitted at time t equals 0 from the primary wavefront sigma. So what you can see here, that if we talk about the surface capital sigma, then these are the points. Let me point taken as P1, that point is taken as your P2, and this point is taken as P3. So these points are these points represent, we can simply say that these points represent the positive optical disturbance. What does it mean? It means we can simply say that the points just inside sigma. Only the positive disturbance of various secondary wavelets are meeting. So these are the points, as I have told you, that P1, this is P2, this is P3. So these points are the points of positive disturbance, whereas if we talk about the point S1, S2, S3, then you can simply say that these are the points which are at the side of the negative optical disturbance. So we have basically two wavefronts. First is your sigma, which is on the side of the negative wavefront, and we have capital sigma, which is on the side of the positive optical disturbance. And we know that if we have two optical disturbance, we have the higher magnitude, we have the lower magnitude, so always the progress will be in the direction of the higher magnitude. Okay, so here in that case, each and every property, whatever having S1, S2, S3, just shifted to the point P1, P2 and P3. So in this pattern we can simply say that the whatever properties are associated by source S1, S2, S3 just carried forward and reaches to the point P1, P2 and P3, and this process continuously going on. So I hope that up to here each and everything is clear to all of you. Now what? As I have told you that the point well inside capital sigma, some of the wavelengths contribute positive disturbance, some other center nearby point sigma produce negative disturbance. So resultant disturbance is 0 at this point. So at S1, S2, S3, the net resultant disturbance becomes 0 due to the negativity of the disturbance. Okay, and if we talk about the point P1, P2, P3, as I have told you, then we have the condition of superposition, and they produce a new wavefront at the geometric envelope of the secondary wavelets. Okay, so basically this represents the secondary wavefront. So we have primary wavefront, we have secondary wavefront. So whatever the property which are carried by the primary pulse, or we can say the pulse which is coming from the source, reaches to the primary wavefront, and after that the same property just forward to the secondary wavefront. This is the unique picture of the Huygens principle, I suppose. Okay. Now on the behalf of this observation, whatever each and everything we have told, we have discussed here, then we are in condition that we can finally construct the diagram which follows the Huygens principle, and that is known as the Huygens construction. So there are few points which we have to consider, and with the help of these points we are in that condition so that we can easily understand that why the law of reflection, why the law of refraction takes place, and how we can draw a primary wavefront, we can draw the secondary wavefront in case of the reflection as well as refraction. So there are a few points, just have a look. First is various points on an arbitrary surface. We know arbitrary surface, that is sigma, as they are reached by a wavefront, become the source of secondary wavelets. So each and every point on the arbitrary surface will the source of the secondary wavelets. The geometrical envelope of these wavelets at any given later instant represent the new position of the wavefront at that instant, means that is the capital sigma. So capital sigma is the new wavefront. This method is quite general, although it was developed on the notion of mechanical wave, it is valid for light wave. So as I have already told you that according to Huygens, initially he believed that light wave can be considered as the mechanical waves, and that's why he treated the ether as the medium. and each and everything what we have discussed that is taken by the property of the mechanical wave, but it is very necessary that we are in need of to understand that each and everything, that the concept of the formation of the primary wavefront, the concept of formation of the secondary wavefront, this is only valid for the optical disturbance only. Okay, we can simply say that for the light waves only, it is not applicable on the mechanical waves. Means in the case of mechanical waves, there is no we can say that the primary wavefront or secondary wavefront, these things are not applicable in that things. The surface used in the Huygens construction may have any arbitrary shape. So this thing is already I have explained to you that the source is covered by any type of arbitrary shape, like this way, like the spherical shape, or whatever the shape you can choose here. Okay, so it is not necessary that we have a particular wavefront should be there. If the medium is homogeneous means the optical property of the medium are same, then light moves forward, does not reflect back. So this is the basic reason we can say that light travels in a straight line and in the forward direction. And we assume therefore that the secondary wavelets are emitted only in the forward direction, and the geometrical envelope of the wavelets is to be taken in the direction of the advancement of the waves. Is there a chance of the medium? Means if medium is changing, then the wave may be reflected from the discontinuity, just as a wave on a string is reflected from a fixed end or a free end. In that case, secondary wavelets on the backward side also be considered. So as I have told you that we have several points here, the point be S1, S2, S3, and this is your secondary wavefront, and the point be P1, P2, P3. And we have the wavefront of disturbance. This is your negative disturbance of each point. This is your positive disturbance of each point, like this way. Okay. And we consider that after that there is a negative disturbance like this way, and then again the positive disturbance. Okay, so this pattern is going on. Now if we consider that there is a change in medium is there, change in medium, and in that time reflection is there also. So if there is a change in medium and reflection as well, then in that case we consider that at the negative disturbance also have a direction to progress the wave. So this thing I hope that you can easily understand. So I hope and I believe that what basically Huygens tries to explain is now clear. So once again, the whole model of the Huygens, or the complete theory of the Huygens, can be explained only on the behalf of 3 points. First is your main source, and from the main source your pulse emerges out. Then we have a surface which is we can say that primary wavefront, and each and every point on this surface will behave like a new source, or the secondary wavelets are originating from the primary wavefront. And after that we have a secondary wavefront. So the secondary wavefront is we can simply say that is the point or a point of the positive optical disturbance. And when the we can say that secondary wavefront is at the positive optical disturbance, then the secondary wavefront will be on the negative optical disturbance. So the each and every property which is on the secondary wavefront just shifted to the primary wavefront just shifted to the secondary wavefront. And this process is going on in the nature, and the light travels in the forward direction. So I hope and I believe that each and everything up to here is clear to all of you. Now what you have to do, you have to just memorize, just think about whatever I have told you, that how the beautiful phenomena it is. There is a source and all possible directions of the light is there, and the pulses are emerging out, and we have a surface, and the points on that surface, and the energy is transmitted to that points also. So this is quite beautiful formula, formula, not formula, this is beautiful concept. So this is a beautiful theory also. So I hope and I believe that each and everything is clear to all of you. So best of luck for watching me, and thanks for watching me, thanks for listening me. Best of luck to all of you. Thank you.